This particular video is going to cover the rest of the bases when we talk about solving a rational equation, and this one is going to primarily deal with binomials and trinomials, but also so binomials and trinomials in the denominator, but also solving a quadratic equation when you get the resulting numerator left. Okay, so when we cancel our denominators, our resulting numerator is going to be a quadratic, and we're going to have to solve that. So let's get into this. Again, steps from the previous video. The first one is I want to find excluded values. So in this particular instance, if I look here, the first n plus 3 and the second n plus 3, they're both the same, right? So that means they're going to have the same excluded value. In this particular instance, our excluded value is n cannot be negative 3. Well, how to get negative 3, you might ask? I'll take the denominator, n equals 0. I solve n equals negative 3. But how come I don't have an excluded value for this denominator here with this 3? That's because there's no variable. When there's no variable, I can't solve an equation because 3 equals 0. I can't like move a variable or move a number and stuff like that. So I don't have one, so therefore there isn't an excluded value on that fraction. Now your second step is to then find an LCD. Okay, so what is our LCD? Hopefully by now for LCDs we can figure out that it's 3 times n plus 3. And then my other one is also 3 times n plus 3 and so on. The reason why you have 3 times n plus 3 is because 3 is the only monomial that's in your denominator, so it has to appear in your new denominator. And then n plus 3 is the only binomial, so it also has to appear. Now, I need to make sure my numerators reflect what happened. So this n plus 2, my denominator there was multiplied by 3, so that has to be multiplied by 3. So that's 3n plus 6. I distributed the 3 to both terms. So it's now a minus. I multiplied this n plus 3 times 3. So this times 3 is just 3. That was easy. Then I multiplied this 3, the denominator, times an n plus 3. So I have to multiply the top by n plus 3. So n plus 1 times n plus 3. Some of you are forgetting the fact that we're multiplying binomials here. So some of you, what you would do is you would say n squared plus 3. That's not right. We're forgetting about a middle term in here. How do I get that middle term? Remember, we do a box when I have binomials and binomials. So it's n plus 1, n plus 3. Now I have my box, n squared, n, 3n, and 3. So it should be n squared plus 4n plus 3, not just n squared plus 3. If you forget to do a box when you're multiplying binomials, you're going to get your values wrong. Okay, it's not even going to be close. It's going to be wrong. Third step. Remember we said cross out denom or denominators, right? And solve. Oh yes, now we're going to have some fun. Probably not, but I am. Okay, so cross out denominators. Shoom, boom, gone, going away. What do I have left? I'm going to kind of write it above so I have a little more space. I have 3n plus 6 minus 3 equals n squared plus 4n plus 3. Now, if you remember from previous units, this is a quadratic equation because I have an n squared term. How do I solve an n squared term? I need to make one side 0. So what I'm going to do over here is I'm going to combine terms. 6 minus 3 is 3 equals n squared plus 4n plus 3. I'm going to bring the 3 over, bring the 3n over, so I get n squared plus n equals 0, right? Because 3 minus 3 cancels, 4n minus 3n becomes 1n, and then that makes this whole side 0, so that's why I get n squared plus n equals 0. So this is going to be an awesome problem to solve. I'll show you both ways to solve it. I'll show you an easier way and then the longer way, and then you can go from there, and you can decide what you want to do. So, actually I'll show you 3 ways to do it real quick. The first way is to factor, so I can pull out an n. I'm left with n plus 1 equals 0. And then remember, before I can say that that's a -1 because that makes that 0. What makes this 0 a 0? So I know my solutions are 0, -1. Those are my answers. Now I got to make sure they all work, right? So then this is my first kind of way to do it. My second way is to take my n squared plus n equals 0, put it into an x to see if it works. It might or might not. In this case, it will. So a times c is 0. This is b, which is 1. So that's 0 and 1. So now how do I solve this? Remember, I take these out and I flip them. I can't really flip 0, but I can flip -1. Then I divide it by a. A is 1. So my answer is 0, -1, and I guess what? I get the same value. Oh my gosh. Yeah, math is awesome. Now your third way is a little more complicated, but we need to know the third way because some of the problems are not going to factor like this. They're not going to be nice. So if I have n squared plus n equals 0, I know that a is 1, b is 1, and c is 0. Yes, quadratic formula time. Oh yeah. So formula is -b plus or minus square root of b squared minus 4ac over 2a. Fill in numbers. -1 plus or minus square root of 1 squared, which is 1, minus 4 times a, which is 1, times c, which is 0. Oh yes, let's go. Over 2 times 1. Let's go. We get -1 plus or minus the square root of 1 minus 0. 4 times 1 times 0 cancels, so that becomes a 0. Over 2, I get, boom, -1 plus or minus the square root of 1 is 1 over 2. This is great. So I get -1 plus 1 over 2 and -1 minus 1 over 2. If I do the math, I get 0 for the first fraction and -1 for the second. Oh my gosh. Same answers in all three methods. Hashtag math. Okay, so make sure you can choose all three of them. You want to do them. You can choose one. You can choose a second or third. Doesn't necessarily matter. You should end up with the same answer all three ways. Some of these problems will not be able to be solved using step 1 or 2. So then you have to go to step 3. Step 1 or 2 not always works. Step 3 always works. So if you're really good with quadratic formula, do step 3. Yes, it might be a little longer, but you know for sure you're going to get your answers correct. Now, how do I know my answers are actually right? Well, because 0 and -1 are not an excluded value, my excluded value is only -3, so I know that my answers are correct. Or, not necessarily correct, but they're at least plausible. Okay, it doesn't contain a -3, so I know that they're at least plausible. Let's look at example number 2 here. I want to, again, do everything on the right-hand side. Find excluded values, LCD, cross out denominator, and solve. First thing I want to do is I want to find excluded values. But before I can find excluded values, I have to factor. This x minus 4 cannot be factored. So that means that my excluded value here is x cannot be 4, because that'll make that 0. This can be factored as x times x minus 4. This gives me a positive 4, right, from over here, but then this x gives me 0. And then this excluded value is 4. So I notice I have two excluded values again. In this case, x cannot be 0 or positive 4. So I found excluded values. Now let's use the simplified or the factored form of my denominators to find out LCDs. So I have my factored forms of my denominators, and I need to make new denominators that contain all of my common denominators, right? My LCD. So if I look at my monomials, it's just this x, so that has to be in all of them. Then it's x minus 4 because that's the only binomial that I have. And all of them contain it, so that even is much better. So what did I do? I multiplied this by x. This one I didn't touch at all because my denominator stayed the same. This 6x I multiplied by x, so I get 6x squared. Oh, I have a squared. That means I have a quadratic. That means I need to do the steps from before. Oh man. Step 3, cross denominators out and solve. What do I have left? I have x plus 1 equals 6x squared. So I'm going to bring the x over, the 1 over. So I get 6x squared minus x minus 1 equals 0. Some of you might be asking, why did I bring the x and the 1 over instead of the 6x squared? The reason for that is I like to have the 6 positive. It just kind of works out better when we're trying to factor and do all my awesome stuff. You don't have to keep it positive. It just works out much better, because then we'll forget to do and divide by a negative later on. So remember, I have 3 different ways I can possibly solve this. So let's try to do all 3. Maybe only one works. I don't know. We're going to find out. So step 1 was take the 6x squared minus x minus 1 and see if I can factor this. Okay, in the last video, I pulled out something they had in common, right? I pulled out like a greatest common factor. They don't have anything in common that's the same, so I can't pull anything out, right? So I can't really solve it by greatest common factor. I can't do that. So let's go to step 2. Step 2 was, if we remember, it was solving via the x, or solving by factoring. So I get negative 6 up here, a negative 1 down there. How can I do that? If I remember my multiplication, I get negative 3 and positive 2. So now remember, I have to take those numbers and flip, 3 and negative 2. Yay, I'm done. No, you're not. You have to divide by a, and then reduce if you can. 3 divided by 6 is 1/2. Negative 2 divided by 6 is negative 1/3. So those are your answers. Now, what happens if you're not very good at factoring? Well, that's where step 3 comes in, or method 3, right? We talked about quadratic formula. So 6x squared minus x minus 1 equals 0. Quadratic formula. Negative b plus or minus square root b squared minus 4ac over 2a. I don't know if that's to a song or nothing. I don't know. I just started singing it, so hopefully I didn't, like, you know, kill your eardrums or anything. If I did, sorry. Fill in numbers. So a is 6, b is negative 1, and c is also negative 1. So let's start filling it in. Negative, remember, negative b means opposite of b, so that's 1 plus or minus the square root of negative 1 squared minus 4 times 6 times negative 1 over 2 times 6. So now let's go further. I get 1 plus or minus the square root. Negative 1 squared is 1. 4 times 6 times 1 is 24. 2 negatives make a positive, so it's really plus 24 over 2 times 6, which is 12, equals 1 plus or minus. 1 plus 24 is 25. The square root of 25 is 5 over 12. So now I can break this up. 1 plus 5 over 12. 1 minus 5 over 12. 1 plus 5 is 6 over 12 is 1/2. And 1 minus 5 over 12. 1 minus 5 is negative 4. Negative 4 over 12 is negative 1/3. And those are the same answers that I got from up here. So they do work, right? Now, remember, we got to check excluded values. Do any of these numbers appear? No, therefore these are my answers. I'll even use a different color for you. Boom, green. All right, those are your answers for this problem. Go ahead and try this problem. Remember to hit pause so you can have time to solve it, and then hit play if you want to find out what you get, if you're right or wrong. So if you notice, I took away the stuff on the right-hand side because this problem could get a little tricky. So I'm going to take that away so I have a little more room to write. I need to first find the excluded values. So when I have excluded values, remember, I need to factor first. So this is really x times x plus 5, and the same thing here, x times x plus 5. There isn't a denominator with the 1, but technically there is. It's just the 1. So what makes this 0? Negative 5. What makes this 0? 0. Since these are the same, so I have two excluded values of 0 and negative 5. So excluded values. X can't be 0 or negative 5. So because my two denominators are exactly the same, x plus 5s, my first and last one, I need to find an LCD for this one. So again, my LCD for all of them are going to be all the same, and it's going to be x times x plus 5, x times x plus 5, and then x times x plus 5. This was the same, so that means 6x minus 30 stays. This was the same, so that means x squared plus 9x plus 18 stays. This numerator, or this denominator, changed. What did I change by? It changed by an x times an x plus 5. But the 1 times all of that is just x squared plus 5x, because 1 times it just gives me what I get. So that's step 2, right? And then step 3 now is to cancel denominators, and let's solve. So I have 6x minus 30 plus x squared plus 5x equals x squared plus 9x plus 18. So now let's bring everything to one side. Okay? So if I bring this x squared over, what do we notice? Ha! It cancels. Subtraction, it cancels. Let's bring the 5x over. That gives me 4x plus 18 is equal to 6x minus 30. Let's bring the 4x over. Gives me 2x equals, bring the 30 over, 48. X equals 24. Boom goes the dynamite. That value, 24, is not an excluded value. Therefore, 24 is your solution to this problem.